Now let us continue forward, sir. Let us now understand how to find the area of similar triangles. Very important topic once again. How to find the area of similar triangles. First of all, let us understand this word called as similar triangle. What is the meaning of similar triangles? As the name suggests, similar is nothing but same, right? Similar is nothing but same. Not exactly the same maybe, but it is equivalent word for similar is same itself. Now suppose for example, let me explain you with an example, or probably let me explain you with diagrams. Suppose I have two triangles. Let me call this triangle as ABC. I have another triangle with me. Let me call this triangle as DEF, right? Let me call this triangle as DEF. Now one way how you can say that two triangles are similar is ABC is exactly same as DEF. That means there is no difference between ABC and DEF, or in other language, if I take this triangle DEF, if I cut the triangle DEF and try to paste it exactly on ABC, there should not be any deviation. That means you should not even understand that you have cut and pasted something on ABC. That is how they both should be. That is one way where you can actually say that these both are similar triangles. That means similar triangles, in this case what I discussed right now is ABC is equal to DEF, AB is equal to DE, BC is equal to EF, AC is equal to DF. Everything remains same. Angles also remains the same, and when you cut it the DEF and paste it on ABC, they should exactly coincide with each other. That means area of this triangle ABC, let me call it as A1, area of this triangle ABC DEF, let me call it as A2. They both should be same, right? They both should be same. That is one of the thing what you can say. Another thing what you can say is if two triangles are similar, if two triangles are similar, I can say the same thing what I explained right now in a different language as if two triangles are similar, then their corresponding angles are equal. Then their corresponding angles will be definitely equal if two triangles are similar. Vice versa is also true. If the corresponding angles are equal of two triangles, then those two triangles will be similar. Is that the only thing? Definitely no. You take the ratio of corresponding sides, ratio of their corresponding sides are also equal. That means what is the understanding is ratio of their corresponding sides also will be equal and corresponding angles also will be equal. Then the two triangles are said to be similar. Sir, can you please explain this? Whatever you have written 2 points, can you please explain this? Now see here, sir. Opposite to angle A, let me call it as side small letter A. Opposite to angle B, it is small letter B. Opposite to angle C, let me call the side as small letter C. Similarly, opposite to angle D, small d. Opposite to angle E, small e. Opposite to angle F, small f. That means, can I say that definitely triangle ABC and triangle DEF will be similar. When will it be similar? When will it be similar? When can you say that it is similar? When the ratio of their corresponding sides are equal. Now before I move on to the corresponding sides, what is the ratio of their area? First of all, area of triangle ABC, which I call it as A1, it is root 3 by 4 into side square. In general, I am talking about root 3 by 4 into side square. So here I will take it as side 1 square because I am talking about the first triangle. Similarly, second triangle area is root 3 by 4 into side 2 square. That means root 3 by 4 will cancel off. That means, can I say that ratio of two areas of two triangles is nothing but equal to, square of their ratio of their side, ratio of square of their corresponding sides. So that is what I have written here also. That means two triangles are similar if ratio of corresponding sides are equal, or the square ratio of the squares of their corresponding sides are equal. That means here the side here is A, which is nothing but the base. The base of DEF is D. That means ratio is A by D. I can square it also, right? I can square it also. Similarly, here the side is B. The corresponding side of a side B is side E in this triangle. So B by E whole square. B by E whole square. Sir, why are you writing square? You told that two triangles are similar if the ratio of corresponding sides are equal. Why are you writing square? Because the area ratio I am talking about here. Ratio of area is nothing but side of the square of the side, whatever it is, right? Square of the side. That is the reason I am writing A by D whole square, B by E whole square, and it is C by F whole square, right? It is C by F whole square. Now, if the side squares are, what do you say, like square of the side is similar, or ratio of the square of the side is nothing but equal to ratio of the area, so square of the side can also be represented as perimeter. Perimeter of first triangle P1, perimeter of second triangle P2. P1 by P2 whole square also I can say it as, because perimeter also, the unit of perimeter is centimeter itself. Unit of side is also centimeter or meter, whatever it is. Similarly, what else is having the unit as meter or centimeter? Height. That means the corresponding height square also it will become. H1 is the height of the first triangle ABC, H2 is the height of the second triangle DEF. So A1 by A2, that means ratio of area of two triangles is equal to square of their corresponding heights. That means it can be equal to ratio of area of two triangles can be equal to square of their corresponding sides, ratio of square of their corresponding sides, or it can also be equal to ratio of square of their corresponding perimeters, or it can also be equal to ratio of square of the corresponding heights. I hope it is very clear for you. In simple language, sir, just to tell in one simple language, area is directly proportional to side square. That is what I have done in all these cases. So area is nothing but equal to side square of first triangle is A square. But if I want to take the ratio with second area, corresponding to A square is which one? It is nothing but in the other triangle DEF it is D square. Similarly, if I only take first area, it is B square. If I take the ratio with the second area, then it becomes area is proportional to side square. So corresponding side of B in the other triangle DEF is E square, and like that the process continues, which what I have written in my previous this particular screen. I hope the idea is very clear. Very important thing. Area of a triangle is proportional to side square. From there only we have derived that entire logic, whatever we have written in this particular screen at the bottom of the screen. I hope this basic understanding is clear. And another thing what you need to know is two triangles are similar if their corresponding angles are similar. What is the meaning of corresponding angles? That means angle A should be equal to, corresponding to angle A, it is angle D in this case. Angle A, angle D should be same. Angle B, angle E should be same. Angle C, angle F should be same. Two triangles are similar if the corresponding angles are equal, and the other case is ratio of corresponding sides are also equal. That means it is A by D should be equal to B by E should be equal to C by F. This is, if this condition is satisfied for these two triangles ABC and DEF, then definitely ABC and DEF are similar triangles. And the other thing which I told you is A should be exactly equal to D, B should be exactly equal to E, and C should be exactly equal to F. If I take exact values also, A by D is, it becomes 1 by 1. B by E also becomes 1 by 1 because B and D are exactly equal. I am taking another scenario. C and F are equal. So 1 by 1. 1 by 1 is equal to 1 by 1 is equal to 1 by 1. So it is true. Therefore, in that case also, two triangles will definitely be similar. In this case, instead of calling it as similar, I can use a much more better word called as two triangles are absolutely same triangles. That means if I cut one triangle and paste it on the vertices of the other triangle, they should exactly coincide, because the sides will be definitely equal and angles will also be definitely equal, and thereby the area is equal. In simple language, sir, one of the way of saying two triangles are similar is nothing but ratio of corresponding sides are equal. But what I will teach you people is in a much more easier understanding way. Two triangles ABC and DEF are similar if all the sides of two triangles are absolutely equal, all the angles of two triangles are absolutely equal, or in simple language, the area of two triangles are 100% same. If area of first triangle A1 is equal to area of second triangle A2, then definitely those two triangles, without any hesitation, I can say that they will be similar, or they both are absolutely same. I hope I am making sense for you people. Another way of understanding this particular logic of similar triangles is, suppose for example I have a triangle ABC. Let me draw it little bigger for our better understanding. I have a triangle. Let me call this triangle as triangle ABC. Now this is the triangle ABC. I have another triangle. Another triangle is the triangle DEF. Right? Another triangle is triangle DEF. Sorry, maybe ADE I can take. Right? So bigger triangle is ABC. Smaller triangle is ADE. Now if you observe carefully, in bigger triangle also this vertex A is taking part. In the smaller triangle ADE also this vertex A is taking part. That means I can say that area of the bigger triangle ABC divided by area of the smaller triangle ADE, this can be written as, I just now told you that area ratio is equal to corresponding sides ratio. That means ABC, if I take this side AB, in AD I should take the same side AD. That means it is AB by AD whole square. That is also equal to, in ABC if I take the base BC, if I take the base BC in ABC, in ADE also I should take the base DE. So it is a BC by DE whole square. Similarly, in ABC I will take this right hand side which is side AC, and right hand side of a small triangle ADE is AE. So AC by AE whole square. I hope everything what I am discussing till now with conceptual clarity, it should be clear for you people. Sir, this is triangle, sir. Can I do the same thing for a square, sir? Definitely. The beauty about a square is, suppose I will take one square, right? I will take a square. So side of this square I will call it as S1, right? Side of this square I will call it as S1. This is my square 1. Let me call the area as A1. Similarly, I have this another square. I will call the area as A2. Side of this square is S2. I will call this as square 2. Second square, side is S2. All the sides are equal in a square. Area of a square in general is nothing but side square, right? Area of a square in general is nothing but side square. So A1 divided by A2, area of the first square divided by area of second square is nothing but area of first square side is S1. So it is S1 square divided by S2 square. It is S1 by S2 whole square. If the area ratio is equal to square of the ratio of the square of the sides, then those two particular geometrical figures will definitely be similar, which I told it in triangle. That means these two squares, square 1 and square 2, definitely are similar. That means in simple language, squares are always similar, right? Squares are always similar. Sir, why do you say that squares are always similar? For the simple reason that you take any two squares, definitely all the sides, all the angles will be 90 degrees only, right sir? If all the angles are 90 degrees, then all the sides also will be equal. So area also can be made equal. That means squares will always be similar. Sir, triangle you said, squares you said for similarity. Can I take it in terms of circle? Definitely. This is the beauty of learning through concept. Suppose I have this circle. Let me call this circle as circle 1, and the radius of this circle is R1. Let it have an area called as A1. I have another circle, diagram not drawn to the scale. Let me delete it and write it one more time, little neatly, sir. It went off awkwardly. So let me draw another circle, probably in a different color. Okay, this also diagram is not too good, please correlate with me. So it is R2 radius, the area I will call it as A2. Area of circle in general is pi r square, where pi is constant. That means area of circle is directly proportional to the square of the radius. That means area 1 divided by area 2 is equal to pi r1 square divided by pi r2 square. It is r1 by r2 whole square. If the ratio of area is equal to ratio of square of corresponding radius, then those two geometrical figures, those two circles in this case, are definitely similar. That means in general, squares are always similar. Circles are also always similar. Any two circles will always be similar. This is the beauty of learning the concept. We have only understood the concept till now. We have never touched any problems till now. Let us now move on to problem solving and understand how easily we can solve all our problems. Let me repeat it one last time. Area of a square is proportional to the side of a square of the side, right? It is proportional to the square of the side. That means I can say that area two triangles are similar if their corresponding angles are similar, if the ratio of their corresponding sides are also equal. That is point number 1. And another thing what I can say is the ratio of the areas of two triangles is equal to ratio of squares of their corresponding sides. It is also equal to ratio of squares of their corresponding perimeters. It is also equal to ratio of squares of their corresponding heights. Everything is there in the bottom of the screen. And I can also use the same property. I can also say in a different language saying that two triangles are definitely similar when all the sides, corresponding sides in the two triangles are absolutely same and the corresponding angles are also equal. That means in simple language, I can take one of the triangle and try to paste it on the other triangle at its vertices. Exactly, if two triangles are coinciding, then the two triangles are similar. And the other thing is, I can say that all the squares are always similar. Ratio of the squares of area of squares is side of the ratio of square of their corresponding sides. Similarly, all circles are also always similar. I hope till here it is very, very clear for you people. Now let us start solving some very, very important questions on this concept. Now see here, sir. Let us start with some easy questions. Majority of the questions what I am solving are your original examination questions, right? Are your original examination questions. Now listen carefully, sir. Listen to this very, very carefully. Some questions are very straightforward questions. Slowly we will scale up the level of difficulty. Now see this first question. It was asked in the year 2007. The area of two equilateral triangles are in the ratio 25:36. That means areas are in the ratio 25:36, right? It is given as areas are in the ratio 25:36. Their altitudes will be in the ratio of what? What will be the ratio of their altitudes? That is your question. Now see here, sir. I already told you this. Ratio of area of two triangles A1 by A2 is nothing but equal to h1 by h2 whole square, where h1 and h2 are altitudes of triangle 1 and triangle 2 respectively. So a1 by a2 is given in the question as 25 divided by 36. So h1 by h2 is nothing but equal to square root of 25 is to square root of 36, which is nothing but 5 is to 6. Answer for this question is 5 is to 6. Very, very straightforward question. Let us understand very easy questions initially and then scale up the level of difficulty. I hope this first question is very, very clear for you people. See the second question, sir. Original SSC question in the year 2013. 360 square centimeter and 250 square centimeter are the ratio of two similar triangles. That means area is what they have given. Sir, how did you find that it is the ratio of an area? Because the unit given is square centimeter. Square centimeter is nothing but area. If it is only centimeter, then it becomes either the side or the perimeter or the height or whatever it is. But because the unit is given in terms of square centimeter, definitely it has to be area. That means area of two similar triangles are given as 360 and 250, which is nothing but 36 is to 25. And it is already mentioned in the question that it is the ratio of two similar triangles. That means definitely first triangles and second triangles are similar. You don't need to prove it also, because it is already given in the question, right? Because it is already given in the question, there is no need for you to prove it. You can directly take it as a conclusion that two triangles are similar because it is given. Now the question is, if the length of one of the sides of the first triangle be 8 centimeter, then the length of corresponding side of the second triangle is how much? That means one of the side is 8, corresponding side length is how much? Now can I say that a1 by a2 is nothing but side I will take it as s1 of the first triangle, and corresponding side of the second triangle I will take it as s2. s1 by s2 whole square, but a1 by a2 whole value is given as 36 by 25. That means s1 is to s2 is nothing but square root of 36 is to square root of 25. That means the first triangle is having a side of 6 centimeter. The corresponding side of the second triangle is 5 centimeter. This is according to the ratio. But the question says the first triangle, the length of one of the sides of the first triangle is, according to question, it is not 6, it seems it should be 8 centimeter. What should be the length of the corresponding side of the second triangle? This is what they are asking. 6 should become 8, multiply by 8 by 6, or in other words it is multiply by, so it is 2 into 4, 2 into 3, multiply by 4 by 3, 5 also multiply by 4 by 3, 5 into 4 by 3 is how much? 20 by 3. 20 by 3 centimeters should be the answer for this question, which is nothing but in mixed fraction. It is 62 by 3 centimeter, which is option C. I hope it is very, very clear for you people. Now please see the third question, sir. Very very good question. Please listen to this very very carefully, sir. Now your question says, two triangles ABC and DEF are similar to each other in which AB is equal to 10 centimeter, DE is equal to 8 centimeter. Okay, let me write it. So there is a triangle called as ABC. Let us understand statement by statement. There is a triangle called as ABC. There is another triangle called as DEF. Right? There is another triangle called as DEF. Now they are saying that two triangles are similar to each other. Already it is given that triangle ABC is similar to triangle DEF. There is no need for you to prove this statement. It is given in the question itself. There is triangle ABC is similar to triangle DEF in which AB is equal to 10 centimeter. This side value is given as 10 centimeter and the corresponding side of the other triangle DEF, DE value is given as 8 centimeter. Corresponding side value DE is given as 8 centimeter. Then find the ratio of area of triangles ABC and DEF. That means I will call the ratio of triangle ABC as A1 and area of triangle ABC as A1 and area of triangle DEF as A2. A1 by A2 they are asking. We already know that A1 by A2 is nothing but AB whole square divided by DE whole square. This is nothing but 10 divided by 8 whole square, right? 10 divided by 8 whole square, which is nothing but 100. Okay, this is 2 into 5, 2 into 4. 5 square is 25, 4 square is 16. Answer for this question is 25 is to 16. The corresponding ratio of the corresponding areas of two triangles ABC and DEF is 25 is to 16, which is nothing but option 2. Now what I will do is, sir, I will call this as my method 1. Sir, is there any other method other than this? I don't think so, right, sir? Because this is what we have studied in our school days. This is what we have studied just now also when you taught the basics. Everything, this is what we studied. Do you think any other thing is there? Definitely we can do it, sir. Now see here. I told you that area of a triangle is directly proportional to side square, right? Area of the triangle is directly proportional to the square of the side, right? It is square of the side. Now what is that it is given? Let us solve it by method 2. First understand method 2 for this question carefully, then the remaining questions which are coming forward becomes very very easy. Now they are saying that triangle ABC is there, right? There is a triangle called as triangle ABC. Triangle DEF should be same. Sorry, DEF is there and it is given in the question that AB is equal to 10 centimeter, DE is equal to 8 centimeters. Let me call the area of first triangle as A1. Let me call the area of first triangle, which I don't know, as A1. Area of the second triangle also I don't know, which is not given in the question. I will call it as A2. Now think logically, sir. In my concept of similar triangles, when I explained you the concept of similar triangles, I told you that two triangles will also be similar if their corresponding sides are equal. That means one thing what we will learn from our textbook methodology is two triangles are similar if the ratio of their corresponding sides are equal. Ratio should be equal according to textbook. But what we will say is, we will say that AB, the side, one of the side in this triangle ABC, in the other triangle DEF, the same corresponding side of AB is nothing but DE. That means I want to make AB equal to DE. Similarly, BC should be equal to EF. CA should be equal to FD. I am saying they should be equal. I am not saying the ratio should be same. I am saying the numerical value itself should be equal. I hope I am making sense for you people, sir. That means, can I say that if AB is equal to DE, let me write it for one question. If AB is equal to DE and BC is equal to EF and AC is equal to DF. If these three sides, corresponding sides of two sides, are absolutely numerically equal, then if I cut this triangle DEF and paste it on triangle ABC, they will exactly coincide. They will coincide in such a way that no person will be able to understand or identify that DEF is actually pasted on ABC. That is how they will both will be coinciding. That means if these three sides, if these three corresponding sides are numerically absolutely equal, then their angles also automatically will become equal. Corresponding angles, angle A will be equal to angle D, corresponding angle B and E will be definitely equal automatically. C and F also will be automatically equal. That means, can I say that in simple language, if this condition happens, then the two areas will be absolutely same. Definitely the two areas will be, no doubt that they both will be absolutely same, because you are coinciding one triangle on the other triangle. Don't worry sir, this is 1 second answer by method 2, but why am I explaining in so detail? So that you will understand the concept better and you will not use so much of waste so much of time in the upcoming problems. That means, can I say that my intention in method 2 is to make AB and DE same. That means AB in my first triangle is given as 10, DE in my second triangle is given as 8, but numerically 10 and 8, they both should be made absolutely equal. I hope I am making sense for you. That means 10 and 8 should become the same number. This I have taught in multiple topics like time and work, time, speed and distance. When two different numbers has to become the same number, you should take the LCM of those two numbers. LCM of 10 and 8 is 40. That means 10 should become 40. Multiply by 4. 10 into 4 is only 40. 8 should become 40. Multiply by 5. That means, can I say that in simple language, think little logically, you will get the answer so beautifully right now. I am multiplying the side by 4. That means area is proportional to side square. Area is proportional to side I multiplied by 4. That means 4 square it will become. So if I multiply side by 4, area should be multiplied by 4 square. That means earlier my area was A1. Now that area should be multiplied by 16, which is 4 square. The new area of this triangle ABC becomes 16A1. Similarly, 8 has to become 40. I multiplied the side by 5. Area is proportional to 5 square then, because side is multiplied by 5. So area should be multiplied by which number then? 5 square. Earlier the area of DEF was A2. Now it will be multiplied by 5 square. So DEF area now becomes 25A2. But I can definitely 100% without any hesitation say that area of triangle ABC will be equal to area of triangle DEF, because AB is equal to DE. That means area of triangle ABC right now is 16A1. Area of triangle DEF right now is 25A2. They both are absolutely equal. They are asking you A1 by A2 ratio, which is nothing but 25 by 16. Believe me sir, method 2 will actually give you the answer within 2 to 3 seconds. But the reason why I explained in so much detail is only for you people to understand it better. Now we will understand this method 2 better in this particular problem, pending little bit of time. And thereby we will save lot of time in solving our upcoming problems in the most easiest way possible. I hope the idea is very clear. Yes, method 1 is something which is there in your textbook sir. You can follow that. Yes, I also followed it here. But I want you to learn the actual meaning of similar triangles. Actual meaning of similar triangles is actually taught in method 2 in this case. I hope I am making sense for you people. Please see the next question. See the next question. SSC CGL Tier 1 asked in 2013. ABC triangle is similar to triangle DEF. Okay, let me write it. There are two triangles. First triangle is triangle ABC and the other triangle is second triangle is triangle DEF, right? Second triangle is triangle DEF. These two triangles are absolutely similar. It is already given in the question. No need to scratch your head whether they are similar or not. They have already mentioned in the question itself, such that BC is equal to 3 centimeter. BC value is given in the question as 3 centimeter. EF value, the corresponding side of BC in the other triangle is EF. It is given in the question as 4 centimeter. Area of triangle ABC is 54. Initially, the area of triangle ABC is given as 54 centimeter, and then find the area of triangle DEF. What is the area of triangle DEF? Let me teach you both the methods once again for your better understanding. If I call the area of triangle ABC as A1 and area of triangle DEF as A2, A1 by A2 ratio will be equal to square ratio of square of their corresponding sides. Value corresponding side given is BC and EF. So it is BC by EF whole square. So this is nothing but A1 by A2 is BC is 3 square is 9, EF is 4 square is 16, but A1 value is given in the question as 54. So this can be written as 54 divided by A2. So 9 into 1, 9 into 6, 16 into 6, it is 96. Area of the second triangle is 96 square centimeter, which is nothing but option C. Yes sir, this is very easy method. Yes, this is a good method also, but I want my student to learn method 2 also, which will actually not make you to write anything but tell the answer looking into the diagram itself. I am writing the diagram once again. Question says triangle ABC is given. Question also says another triangle DEF is given. Diagram is not drawn to the scale. Question again says that these two triangles are absolutely similar. There is no need to prove it and waste your time. It is already given in the question. Question also once again says that BC value is 3 centimeter, EF value is 4 centimeter, and 54 is the area of the first triangle. What should be the area of the second triangle DEF? That is the question. Now see here sir, simple common sense. I already taught you method 2 in my previous question. Same logic I would like to implement sir. Can I say that if two triangles have to be similar, then the corresponding sides numerical value should be equal. BC value here is 3, here EF value is 4, but they both should be equal. What is the LCM of 3 and 4? 12. That means 3 should be multiplied by 4, then it becomes 12, right? I hope I am making sense. Then it becomes 12. If I am multiplying one of the side by 4, then the area should be multiplied by 16. 4 square it should be multiplied with. Similarly, I don't know the area of second triangle. I will call it as A2. Initial area, let me call it as A2. 4 is the side of EF, but it should become 12. 4 into which number is 12? 4 into 3 is 12. Now, this side, one of the side is multiplied by 3. Area should be multiplied by 3 square. How beautiful it can be, sir. Now, can I say that because these two sides are absolutely same, these two areas will be absolutely equal. That means 9 into 1, 9 into 6 over A2 will be equal to 16 into 6, 96 centimeter square. You don't require anything to be written as A1 by A2 is BC by EF whole square. Substitute BC, nothing sir. Simple common sense, you will be able to solve the question in the much more easiest format, and that too in diagram itself. Common sense should be there. That's all for all of us, and that is what I want to teach you people, how to use our basic common sense. Similar is nothing but same, right? The other meaning of similar or the other name for similar is same, right? Or the same name for similar is same. Rather, I can put it like this. Similar means same. That means all the sides should be same, corresponding side should be same. First triangle BC if I take, second triangle corresponding side should be EF, right? That means BC is 3, EF is 4. My god, they both are different, right? They both should be same. Make it same. Simple. 3 into 4 is 12. 4 into 3 is 12. That means in the first triangle, you are multiplying the side by 4. That means area should be multiplied by 16 from the original area 54. Similarly, in the second triangle, you are multiplying the side by 3. That means area should be multiplied by 9 with your original area A2. If these two sides are numerically equal, then the areas will be numerically same. Equate it, simplify, you will get the answer. Do not worry, sir. I will take more and more problems where we can solve it so easily and beautifully by using method 2. In diagram itself, we can solve it, so that there is no need for all of us to write everything in detail in our examination hall. Probably I will write it. Method 1 and method 2 I will write and explain you in this particular class in so many problems, only for you to understand which is the better method going forward. But you need not write method 1 and method 2 in your examination and waste your time. Apply any one method which you are comfortable. I personally believe that method 2 will give you the answer little fast, because you can solve it in diagram itself, and that too probably without looking into the, without using pen also you can solve it in some cases. I hope the idea is very, very clear for you people. See the next question, sir. See this question. Question is, if the ratio of area of two squares is 225 is to 226, A1 divided by A2, it is given as 225 is to 226, right? Is to 220, sorry, to not 226, it is 256. 225 is to 256. They are asking you to find the ratio of their perimeters. We already know that A1 by A2 is nothing but perimeter 1 by perimeter 2 whole square, but A1 by A2 value is known to us as 225 divided by 226. So P1 by P2 is what they are asking. So it is square root of 225, 15 square root of 256. Again I am writing 226. Why is that I am making so much of mistake in this problem? It is 256. Square root of 256 is 16. Answer is 15 is to 16, which is nothing but option C. Sir, can I solve it by using method 2 which you taught in our two problems earlier? Yes, definitely, because perimeter is nothing but sum of three sides. In the previous question we only took one side. It makes no difference. I hope I am making sense for you people, sir. Next question. Next question. Question says, triangle ABC is similar to triangle DEF. It is given already that ABC and DEF are similar triangles, so no need to prove it. The ratio of their perimeters is 4:1. P1 by P2 is given as 4:1. Find the ratio of their areas. A1 by A2 they are asking. This is nothing but my reverse question, reverse of previous question. A1 by A2 is P1 by P2 whole square. P1 by P2 is 4 by 1 whole square, which is nothing but 16:1, which is option B. It is the original examination SSC CGL 2015 question. Re-examination happened in tier 1. So that is the question. In the previous question, area ratio was given, perimeter ratio was asked. In this question, perimeter ratio is given, area ratio is asked. See the next question, sir. See this next question. Your question says, now I believe that you should be able to solve this little faster in method 2 compared to what we have solved in our previous two problems where we applied method 2. Now see, let us read the question. The area of two similar triangles ABC and DEF are 20 and 45 square centimeter respectively. Okay, there is a triangle ABC, beautiful. The area of this triangle is 20. Area of another similar triangle DEF, it is given in the question as 45. it is also given that AB is equal to 5 centimeter, then DE is equal to question mark. Now in method 1, which we use our textbook method, I can solve it saying that as area of triangle ABC, which I call it as A1, divided by area of triangle DEF, which I call it as A2, is equal to AB divided by DE whole square. But area of triangle ABC and DEF are given as 20 divided by 45. AB value is 5 square divided by DE is what we need to find. The only unknown variable in this question is DE. You can simplify, you will get the answer. 5 square is 5 into 5. So this is 5 into 5 is 25, 5 into 4 is 20. And then what are you left with? So DE will be equal to 45 into 5. 45 into 5, right? 45 into 5. Okay, DE square, right sir? This is, yes, this is DE square. So DE square will be 45 into 5 divided by 4. 45 can also be written as 9 into 5. 9 into 5 into 5, that is nothing but 9 into 5 square divided by 4. I want DE value. This is square root of 9, which is 3. Square root of 5 square, which is 5. Square root of 4, which is 2. So this is 15 by 2. 7.5 centimeters should be the answer for this question, which is nothing but option B. Now this is my method 1, sir. Can I solve this question by method 2 without writing all those dramas what we have written there? Yes, definitely, sir. That is the beauty of learning the concept. This is my triangle ABC. This is my triangle DEF. Diagram not drawn to the scale. So it is not looking like both the areas are equal, but assume that I am making both the areas are equal. Now see here, it is given in the question that initial area of triangle ABC is 20. Initial area of triangle DEF is 45. Now areas are not equal initially, but I want to make it equal. How will I make it equal? AB is given as 3. DE I don't know, right? I don't know the value of DE. That is what is you need to understand. DE is something which is asked in the question. Is there any other thing which is given in the question? Definitely no. Sorry, AB is given as 5, sir, not 3, right? AB is given in the question as 5, right? Let me erase that. Let me erase it. AB is given in the question as 5. DE is what they are asking you in the question. Now see here, sir. Same logic. In all our previous questions, we were trying to make the side equal so that the area becomes equal. In this question, we will make our area equal so that the side will become equal. I hope I am making sense for you, sir. This is the beauty of learning through concept. Now, area of the first triangle is 20. Area of the second triangle is 45. They both should be equal for it to be a similar triangle, for them to be similar. That means 20 and 45 should become the same number. That is nothing but the LCM of 20 and 45. LCM of 20 and 45 is 180. Sir, how 180? Refer to my time and work class. I taught you how to find the LCM also in the most easiest format. That means 20 should become 180. Multiply by 9. Now understand carefully. In the previous case, if you multiply side by 9, for example, if you multiply side by 9, then area you are multiplying by 9 square. In this case, you are multiplying area by 9. That means side should be multiplied by square root of 9, which is 3. I hope I am making sense. That means, now see ulta, sir, if I multiplied side by 3, then area should be multiplied by 9. That only I did here. I hope I am making sense. Similarly, A2 also should be 180. 45 into which number is 180? 45 into 4 is 180. Area is multiplied by 4. That means side should be multiplied by 2. Earlier there was some side. I don't know how much it was. Now that side is multiplied by 2. And I also know that because the areas are equal right now, these two sides also will be equal. That means 3 into 5 is 15. DE also should be 15. That means initially what was the value of DE then? 2 into which number is 15? 2 into 7.5 is only 15. That means earlier DE value was how much? 7.5. That means that should be my answer, which I also got the same value in my method 1. I don't even have to write all these things, sir. Do you think you need to write all these things? Definitely no. Definitely you don't need to write all these things. You should know that A1 should be equal to A2. So 20 into which number is 180? Okay, 9. Okay, multiply side 5 by 3 then. So here also 45 into which number is 180? 45 into 4 is 180. Okay, side should be multiplied by 2. Earlier side was something, I don't know, some value was there for DE. Now I am multiplying it by 2. 2 into which number will become 3 into 5, 15. 2 into 7.5. That means the original value of DE is 7.5. Over. This is how you need to solve. This is exactly how you need to solve, sir. And believe me, the way you solve this kind of questions in this manner will determine how beautifully you can solve all the questions in your examination in your coming problems. I hope I am making sense for you. Next question. See this question, sir. Again, it's a very good question. Now let us solve this original SSC question which had come in the year 2013. Now see here. Let us read the question, understand it, draw it, and then solve it in the most easiest way possible. In triangle ABC, D and E are the points of sides AB and BC respectively. Hold on. Let me draw triangle ABC. Then I will get little clarity. In triangle ABC, okay, this is the triangle ABC. Question says D and E are points on AB. There is a point on AB, right? There is a point on AB that is nothing, sorry, AB, right? So AB, okay, AB and BC, right? AB and BC. Okay, let me name these triangles as let me use the naming conventions little different, sir, so that it becomes easier for us to understand. Instead of writing ABC here, what I will do is, let me write ABC here so that it becomes easier for our diagram. I will write ABC here. So question says, in triangle ABC, D and E are the points of sides AB and BC respectively. There is a side AB. On that AB there is a point called as D. On side BC, so BC, there is a point called as E, right? So BC, right? That means this should also be, I think. Let me draw the diagram neatly, sir. Okay, don't worry, I will solve it once again. Do not worry about it. Now please see my next question. Your question is, in triangle ABC, okay, let us draw the triangle. Let me draw the triangle ABC, then we will understand what all the points, what are the data which is given. In triangle ABC, D and E are the points on AB and BC respectively. On AB I have a point called as D. On BC I have a point called as E. So D and E are the points on AB and BC respectively, such that DE is parallel to AC, right? This line DE is parallel to AC. Yes, DE is parallel to AC. Beautiful. And they have not given in the question that D and E are midpoints. If it is midpoint, I would have taken it as 1 and 1, 1 and 1. But what else is given in the question is AD is to DB. AD is to DB is 3 is to 2. That means if this is 3, this should be 2. AD is to DB. It is given in the question as 3:2. What is the question? Find the ratio of area of trapezium ACED. Trapezium ACED. This trapezium ratio, this downward trapezium ratio to that of triangle BED. BED, this upward triangle ratio. This ratio is what I require. Now see here, sir. I don't know the ratio of triangle BDE, right? BDE. Let me call it as A1, right? Let me call it as A1. I also don't know the triangle area of the trapezium ACED. Let me call that area as A2. Now, think little logically. I definitely know one beautiful property, one very important property known as area is nothing but proportional to side square. Area is directly proportional to the square of the side. That means, can I say that if I forget about this trapezium as of now, forget about this trapezium, can I say like this, sir? Think logically. This A2, whatever I have called right now, let it not be the area of trapezium. Let me take the area of area A2 as the area of this bigger triangle. That means, let me write it if you are getting confused. Area of triangle BDE, which is the smaller triangle, divided by area of triangle bigger triangle ABC. Area of BDE divided by area of ABC is, in BDE, side is 2, right? Side is 2. Side square is 2 square, which is 4. Similarly, the corresponding side in ABC is, if I take BD here, then the corresponding side in ABC is BA. BA totally will be how much? 3 plus 2, it will be 5. So it will be side square 5 square 25. That means, can I say like this? Let me write and show it to you. Smaller triangle is BDE. This is having the area of 4 centimeters or whatever it is. Bigger triangle is BAC. This is having the area of 25. But what I want is not the bigger triangle area. I only need the area of this trapezium. That means, from the entire bigger triangle 25, from the entire bigger triangle 25, remove this smaller triangle 4 units. That means, trapezium will be left with 25 minus 4, 21 units. From the entire triangle 25, from the entire bigger triangle 25, remove this smaller triangle, area of 4 units. Then I will be left with area of the trapezium, which is 25 minus 4, which is 21 units. That means, area of trapezium ACED, which is 21, ratio with area of triangle BED. BED is how much? It is 4, right? It is 4. Answer for this question is 21:4, which is nothing but option D. Please be careful. There is another option called as 4:21, which is just the reverse of this first option. So, sorry, correct answer 21:4. Reverse is 4:21. Don't be in a hurry to mark it as 4:21. Answer is definitely not 4:21. Answer is 21:4, because they are asking you to find the area of trapezium ACED to the area of triangle BED. Trapezium means bigger outer triangle ABC. From that, remove that smaller triangle BED. 25 minus 4. From this entire 25, remove this 4. You will be left with the trapezium. You will be left with this trapezium. 25 minus 4, 21. And smaller triangle is 4. So 21:4 should be the area. Do not worry, sir. This is your examination question. Let me take another question for your better understanding, which is also your examination question. See here. Please see the next question, sir. See the next question. This is where we will understand with multiple questions and solve it in the most easiest way possible. Similar kind of question what I have solved in my previous question. In triangle ABC, okay, let me draw a triangle ABC. Let me name the triangle as ABC. In triangle ABC, D and E are 2 points such that D and E are 2 points on sides AB and AC respectively, such that DE is parallel to BC, DE is parallel to BC, and AD is to BD, AD is to BD. It is 2 is to 3. That means AD is 2, BD is 3. Total AB, if I want, it is 2 plus 3, 5. Then you need to find the area of trapezium DECB to the area of triangle ABC. Now they are not asking you to find the area of trapezium with the smaller triangle. They are asking you to find the area of trapezium with the bigger triangle. One beautiful thing what we know is area of a triangle is directly proportional to side square. That means area of the smaller triangle ADE is nothing but equal to side square. Side of the triangle is given as, one of the side is given as 2. It is 2 square. So area is directly proportional to 4 in this case. That means this smaller triangle area, is 4 unit square, right? 4 unit square. Similarly, bigger triangle side ABC is the bigger triangle. One of the side of the bigger triangle is 3 plus 2, 5 unit. So it is, the area is proportional to 5 square. 5 square is nothing but 25. That means entire bigger triangle ABC square, ABC is having 25. That means total from A to B to B to C to C to A, it is 25. It is 25. But ADE is only 4. That means this trapezium should be another 21. Then only total is 21 plus 4, which is 25. Now what is that they are asking? Trapezium area is 21. Ratio with area of ABC, bigger triangle, is the total 4 plus 21, 25. 21 is to 25 should be the answer, which is option B. Please kindly avoid using let one of the other side be X and other things, sir. Textbook methods will not give you the, it will give you the answer but not in the best way. Kindly follow ANC channel, which will help you to clear any question in aptitude in any of the competitive examinations. I believe that by now you should be very clear with whatever I said the statement right now. Any question, sir, you learn the concept, you can crack any examination, any question so beautifully in the most easiest way possible, and that too without using variable, that too without using formulas. I hope it is very clear for you people. Please see the next question. Again, one more beautiful question. SSC CGL Tier 1 examination question in the year 2013. ABC is a right angled triangle. Let us draw statement by statement. There is a triangle which is given and it is said that it is triangle ABC. It is also said that it's a right angled triangle angled at angle B, right? 90 degrees at angled B. Now see here. B being the right angled, yes, I already wrote it in the diagram itself. B being the right angle, midpoints of BC and AC are respectively B dash and A dash. The midpoint of BC is B dash, right? The midpoint of BC is B dash. The midpoint of AC is A dash, right? This is the midpoint of AC. That means if I join these two, B dash and A dash, that B dash and A dash will be parallel to this base AB, right? B dash A dash will be parallel to the base AB. Now question asks, find the ratio of area of quadrilateral AA dash B dash B, AA dash B dash B, and the area of the triangle ABC. ABC is nothing but the bigger triangle. Same logic, sir. The beauty about this question is, because the question is asked for midpoint, so if I call C dash CB dash as 1 unit, then BB dash also will become 1 unit. Similarly, if I call A dash C as 1 unit, then a dash also will become 1 unit. So total will become 1 plus 1 2 units, because that is the midpoint. A dash is the midpoint in that case. Similarly b dash, sorry, bc also will become 2 units. If you want to write, you can write it. Otherwise any one of the side is required to find the corresponding side. So one is enough, so you can eliminate the other one if required. Right now see here, sir, can I say like this right now, sir? Can I say that if I take the area, if I take the area of this bigger triangle, first of all, area of triangle is proportional to square of the side, right? Area of triangle is proportional to square of the side. If I take this bigger triangle ABC, in this bigger triangle ABC, can I say that one of the side is 2 units? So area is proportional to 2 square. So area of this bigger triangle ABC will be 4 units, which will be proportional to 4 units, or you can take it as 4 itself. Similarly, if I take this smaller triangle is CB dash A dash. CB dash A dash, one of the side is 1 unit. So 1 square is nothing but 1. So this will be 1. So this smaller triangle is 1. Entire bigger triangle is 4. That means that the remaining trapezium should be 3, because 3 plus 1 only will form a bigger triangle as 4 units. Question is, find the area of quadrilateral. Area of quadrilateral is 3 units. Only one option is there which is starting with 3. You can mark it and move ahead, or if you want to cross check, area of triangle ABC. Triangle ABC is 4 units. So answer is 3:4, which is option C. Next question, sir. Please see this question. A very good question, not too much difficult question in fact, but you can solve it very easily, sir. Question says, examination question in 2015, two isosceles triangle have equal vertical angles. What is the meaning of vertical angles? I believe that you might have heard about an angle called as vertically opposite angle. Vertically opposite angle or vertical angles are nothing but the triangles will share the same vertex, but because it is talking about two triangles, they will share the same corresponding vertex. That means if this angle is the vertical, if the vertex which I am taking, then the corresponding vertex in the other triangle should be this. That means these two angles should be same, and these two angles are isosceles triangle. That is what is given, and their areas are in the ratio 9:16. Now can I say that one thing which you should definitely understand is, can I say like this, sir? If isosceles triangle is given, in an isosceles triangle, please know this beautiful property, sir. In an isosceles triangle, if vertical angles are same, right? Question says that they have equal vertical angles. If vertical angles are same, again I am repeating, what is the meaning of vertical angles? Vertical angle means they share the same vertex, but because they are two triangles, they share the same corresponding vertex. So in isosceles triangle, if vertical angles are same, then those two triangles are definitely similar triangles. In this question, they are not directly giving it as similar triangles, but they are saying that it's an isosceles triangle. That is the first important key point, and they are saying that they are sharing the same vertex. That means they are having the same vertical angle. So if two triangles are similar, area 1 by area 2 is nothing but equal to h1 divided by h2 whole square, where h1 and h2 are heights of their corresponding triangle, or two triangle corresponding heights are represented as h1 and h2. Area ratio is given in the question as 9:16. So corresponding heights will be in the ratio square root of 9 is to square root of 16, which is 3:4, which is option D. Next question, again SSC CGL Tier 1 question 2015. Given that triangle ABC is similar to triangle PQR. In this question it is directly given. In the previous question it was not given, but the other information what was given in the previous question was two triangles are similar, no, not similar directly, it is given two triangles are isosceles and they have the same vertical angles. From there we found out that they are similar. So in this question it is directly given, no need to worry about it. It is also given that if I call area, okay, let me write it, sir, for your understanding, so let me not make you so much confused. So this is a triangle ABC, for example. This is the triangle PQR, right? This is triangle PQR. Now triangle PQR area I will call it as A1. Triangle ABC area I will call it as A2. Question says area of PQR, I called it as A1, divided by area of ABC, I called it as A2. A1 by A2 is given as 256 divided by 441, right? 256 divided by 441. PR value is given as 7 centimeter. AC value is how much? Now I know that area of two triangle, ratio of area of two triangles is equal to side square of the ratio of the corresponding sides. That means ratio square of some corresponding sides. That means A1 value, what is A1 value, sir? A1 value, A1 is nothing but triangle PQR, so it is nothing but 7, right? PR value is 7. In A2 is ABC, so AC value I don't know, which is what is asked, so this is whole square. So that means can I say that square root of 256 is 16, square root of 441 is 21, 16 by 21 is 7 divided by AC, right? 16 by 21 is 7 divided by AC. So AC value will be equal to 21 into 7. 21 into 7 divided by 16. Is it, can you multiply with some value in this case? 21 into 16 divided by 7. Is it going in any multiple, sir? Definitely no. 21 into 7 is 147. 147 divided by 16. When you calculate 147 by 16, 147, check it out and calculate by 16, you will get the answer as 9.1875 centimeters, and that is the value of your AC. AC value is 9.1875 centimeter. Probably somewhere they have done mistake while typing the questions, which is not given in the answer options. Kindly mark that answer option also, sir. Answer for this question is option E, which I just posted right now. Maybe while typing they might have typed, usually our typist will type a lot of questions what we have from our database, from our own database what we have created. They will type a lot of questions, because what we do is we will just write it in a sheet of paper, we will create some questions and then we will give it. But this is becoming an examination question. They would have taken from the source of original examination itself. While typing they probably might have typed some wrong answer options. Very rarely they do it, but this is one such case. Sincere apologies. So I am marking my fifth option, which is the correct answer for this question, as 9.1875. I hope the idea is very, very clear for you people, sir. See this question, sir. SSC Constable 2015 question. Your question is, the amount of rice produced in a square field of side 50 meter is 750 kgs. That means it is a square field, right? It is a square field and side is given as 50 meters. Amount of rice produced in this square field, that means they will take the entire square field to produce 750 kgs. They will take the entire square field to produce that 750 kgs of rice. Or in other language I can say that area of this particular square which I have drawn right now is 750 meter square, or whatever it is. It is given in kgs, but you can take it as 750 meter square. So side is given as 50. Now the amount of rice produced in a similar square field of side 100 meter will be how much? That means Now the side becomes 100 meters. The side now becomes 100 meter. What is the amount of square produced in the second square, or in simple language, what is the area of the second square is the question. Now see here, sir. Beautiful logic. Let us eliminate that method 1. Let us switch on to method 2 directly. Now I know that area of these two squares fields are similar only when the corresponding sides the numerical values are equal. Here the value is 100. Here also it should be 100. All the values should become 100. That means multiply this side by 2. Every side rather, because side of a square is, all the sides of a square are equal. That means I am multiplying the side value by 2. If I multiply the side value by 2, this becomes 100, which is similar to this right hand side square or the second square which I have drawn in this screen. That means if the side is multiplied by 2, area should be multiplied by 2 square. That means area of this bigger square, or this square only rather, it is 750 into 4, which is nothing but 3000. How beautifully within second you can solve it, sir. Why are you wasting so much of time by using that method 1? Oh, area of a square, it is nothing but a1 by a2 whole square is nothing but equal to 50 by 100 whole square. Sorry, a1 by a2 is equal to 50 by 100 whole square. So 1 by 2 whole square, 1 by 4. So a1 is given as 750. 750 by a2 is equal to 1 by 4. So a2 is equal to 750 into 4, which is again 3000 only. Why are you writing all these things? Common sense should make us solve the problems in the much more easiest format. I hope it should be very clear for you people, sir. Method 2 is, at least for me, the beautiful methods. I believe it is beautiful. I don't know whether you will take it beautifully or not. It's completely up to you people. See the next question. Again, it's a very beautiful question. Original question which had come in the examination in the year 2015. Now see here, sir. See here. ABCD is a square. Let us draw one by one information. Let us understand it and then write it, so that we will not have any problem in solving this question. Now the first statement is ABCD. It is a square. Beautiful. First statement is absolutely clear. Draw triangle QBC on side BC, considering BC as a base. That means they are asking you to draw a triangle QBC. There is a triangle QBC which I need to draw. That means taking BC as my base, I should draw a triangle QBC. This is what they are actually referring to in the question. Considering BC as my base. Beautiful. That also is clear right now. And draw a triangle PAC on AC as its base. That means I want to make the base of the second triangle as AC. AC is nothing but the diagonal of the square. Keeping that AC as the base, I should draw a triangle PAC. There is some point called as P here. So I should draw this triangle PAC, keeping AC as the base. Diagram is not drawn to the scale. Let me draw it as neatly as possible. So this is the triangle. This is the triangle PAC, right? I hope the second point is also very clear, such that QBC and PAC triangles are similar. This drawn triangle, the constructed two triangles, triangle QBC which I constructed and triangle PAC which I also constructed, they both are absolutely similar. Because these both are similar, areas also will be similar. That means QBC, I will call it as a smaller triangle. I don't know the area of the smaller triangle QBC. Let me call it as QAS. AS means area of smaller triangle, and I am representing smaller triangle as QBC. Similarly, PAC area. PAC is a bigger triangle. I will represent the area of that bigger triangle as AB, which is nothing but area of PAC. Now, can I take like this, sir? Can I say that ABCD is a square I will take each side as 1 unit or 1 centimeter, whatever it is. I will take each side as 1 unit. Now, if all these sides are 1 unit, then the area of the or the diagonal of the square will be root 2 units, which you already is aware of. Diagonal of that square is root 2 units. Now, think little logically, sir. The question says, in the question they are so easily or beautifully saying that this triangle QBC, which I called it as smaller triangle, is similar to this triangle PAC, which I called it as bigger triangle. That means the areas of QBC and areas of PAC should be same. Area of QBC is AS, area of PAC is AB. They both should be same. That means area should be same, means their corresponding sides also should be same. Can I say that the side of this QBC is BC, it is 1 unit, but the side of PAC is AC, it is root 2 unit. They both should be same. 1 unit is the side of one of the triangle, other triangle side is root 2, but they both should be numerically same. That means make this 1 as root 2. If I make this 1 as root 2, multiply this by root 2. If I multiply the side by root 2, then the area should be multiplied by root 2 whole square 2. That means this smaller triangle is now having the area as 2AS. Similarly, AC is the side of this bigger triangle, that also should be made root 2. Multiply root 2 by 1. Root 2 into 1 is root 2 itself. If the side is multiplied by 1, area should be multiplied by 1 square, which is 1. That means the area of the bigger triangle now is AB into 1, but they both should be equal. So they are asking you, find the ratio of smaller triangle to bigger triangle, which is nothing but 1:2. Can't it be done by diagram itself, sir? I directly applied method 2 here. This is the beauty. This is the beauty. In diagram itself, everything I wrote it off then and there itself. Anyway, I should write the diagram for my better understanding in the exam. There itself I will calculate who will write all those things. It is nothing but BC by AC whole square. So then it is 1 by root 2 whole square, 1 by... So who will write all these things? Common sense should say that area should be equal, make the sides equal and multiply with corresponding area. Simple. Over. Next question. Next question. See this question, sir. This is a very good question. Please pay complete attention for this question. Original SSC CGL Tier 2 2015 question. In trapezium ABCD. Okay. Whatever is given, let us draw it off, sir. So that statement is a waste statement for us because we represented in diagram right now. There is a trapezium ABCD. That means in this question I can delete this statement. I already wrote it off in diagram. That is the meaning of it. AB is parallel to CD. AB is parallel to CD. Beautiful. That also I have drawn it already. Next. And AB is equal to 2 times of CD. That means this value of AB is double the value of CD. Or in simple language I can say that if AB value, if CD value is 1 unit, then AB value will be double. I will make it as 2 units. It is also given that its diagonals intersect at O. Diagonal AC and diagram not drawn to the scale once again. Let me delete it, write it one more time neatly. Diagonal here is AC and the other diagonal here is BD. They will intersect at a point called as O. Beautiful. This also is clear. If the area of triangle AOB, this downward triangle is 84 square centimeter, this down triangle is given as 84 square centimeter, then find the area of triangle COD. Up triangle area I need to find. Upper triangle area I need to find. Now, can I say that first of all, is it given in the question already that AOB and COD are similar triangles? No, it is not given in the question. But I already learned from one of the question that AOB is having this vertex O. COD is also having the vertex O. That means the two triangles are sharing the same vertex. They both are vertically opposite angles, right? These two are vertically opposite angles. Because of that, I can say that triangle AOB is similar to triangle COD. What is the meaning of similar? Similar triangle is nothing but area should be same. That means earlier there was some area here. Earlier there was some area here in COD. I don't know what is that area. Let me call that area as A1. Let me call that area as A1. But that area should become 84, or let me teach you in this way so that you will understand it better, sir. First of all, for areas to be equal, sides should be equal. Here the side is 2, but here the corresponding side is 1. Multiply this by 2. If you are multiplying the first what do you say, if you are multiplying one of the side of triangle COD by 2, then the area should be multiplied by 4, right? Area should be multiplied by 4. Earlier there was some area, I don't know how much it is. That area should be multiplied right now with 4. When I multiply this with 4, it should be equal to 84. Which number into 4 is 84? 21 into 4 is 84. Area of COD is 21. Over. Did I write anything? I don't even have to write this, sir. I wrote it for your better understanding, that's all. Sir, can you please tell us how to solve it in method 1? Yes, that also I will show you. Already method 2 I explained it in diagram. Method 1 also let me explain. Area of triangle AOB, which is the down triangle, divided by area of triangle COD. So, area of triangle AOB, one of the side is AB. COD, the corresponding side is CD whole square. AOB, AB is 2x, or if I take it as 2, it is okay. CD is 1, so it is 2 by 1 whole square. That means it is nothing but 4:1. Area of triangle AOB is given as 84. CD is what COD is what we are finding. So it is 84 divided by 4. 21. You got, after writing all these things, do you exactly need to write all these things? I don't think so, sir. In the diagram itself you can so beautifully find it. That is exactly what I wanted to teach you people. Kindly avoid using this methods once, which is the textbook method, and waste your time in the exam. Let us solve beautifully by using method 2 itself, which will save our time to a larger extent. Now, this is one of the question which was asked in examination in 2015. Let me solve a similar kind of question, which is again your examination question. See this question, sir. Exactly similar kind of question. In the previous question, one side was 2 times of other side. In this question, one side is 4 times of other. First, let us read the question. ABCD is a trapezium. Let me draw it. The beauty about this is your CGL question. SSC CGL question in 2017, right? It is in the year 2017. Now see here, they are saying that ABCD is a trapezium. Okay, let me name it. This is ABCD, in which AB is parallel to CD. Yes, sorry, this is D, right, sir? I wrote it as B by mistake. So this is ABCD. Right, this is ABCD. AB is parallel to CD. Beautiful, it's already parallel. AB is equal to 4 times of CD. That means if I take CD value as 1, AB value will be 4 times of that 1. Beautiful, this is also clear. The diagonals of the trapezium intersect at O. Same like my previous question. Diagonals intersect at O. Now they both, these two above and top and bottom triangles are sharing the same vertex. So they are vertically opposite angles. Therefore I can say that triangle COD and triangle AOB are absolutely similar. I hope this part is also very clear for you people. What is the ratio of area of triangle COD to the area of triangle AOB? In the previous question they had given the value as 84 here and you were supposed to find the other value. Now it is not asked for value, they are asking you to find the ratio of it. Let me explain you by method 1 also, sir, for this question once again. So one of the triangle is triangle DOC or COD, whatever it is. Another triangle is triangle AOB. You are writing all these things and explaining and solving this question. So in DOC corresponding side is CD. In AOB corresponding side is AB. It is CD by AB whole square. CD value is 1. AB value is 4. So 1 by 4 whole square is 1 by 16. So you will write all these things and mark the option as option D. No need to write. Simple common sense should say each one of us that if I call the area of this upper triangle as smaller triangle as AS and down triangle bigger triangle as AB, I can say that initially these are AS and AB, but I want to make area same. How will I make the area same? By making the side same. That means the 4 and 1 should be same. 1 should become 4, multiply by 4. If I multiplied side by 4, area is multiplied by 16. 4 should become 1, multiply by 1. If I multiplied side by 1, area is multiplied by 1. That means AS into 16 and AB into 1, they both are absolutely same. AS divided by AB they are asking, which is nothing but 1 by 16. You apply method 1 or method 2, both will give you the same answer, but I personally suggest you to apply method 2 so that you can solve all the numerical values in the diagram itself. No need to write all these histories in the examination and waste your time in the examination. Next, a beautiful question had come in similar triangles in the year 2003, but this time it is not the SSC exam, but it is one of the toughest examination in India, which is nothing but CAT exam. CAT 2003 original examination question. Let us read the question right now, sir. A piece of paper is in the shape of a right angled triangle. That means there is a right angled triangle. A piece of paper is in the shape of a right angled triangle. For our better understanding, let me call this right angled triangle as ABC, which is 90 degrees at angle B, and is cut along a line that is parallel to the hypotenuse, leaving a smaller triangle. Now, what I will do is, I will cut this bigger triangle in such that this point let me call it as cut 1, this point let me call it as cut 2. When I join these two points, these 2 points when I join, it is definitely parallel to the hypotenuse. Diagram is not drawn to the scale once again. It is definitely parallel to the hypotenuse. That is how I will cut. So C1 and C2 2 points. Now that is what is given, leaving a smaller triangle. Yes, BC1 C2 is a smaller triangle right now. There was a 35% reduction in the length of the hypotenuse of the triangle. That means earlier if the hypotenuse was 100 centimeter, earlier if the hypotenuse was 100 inches or whatever it is, now there is a 35% reduction. 35% of 100 is 35 reduction. That means the new length of the hypotenuse is 100 minus 35, which is 65 inches. Question is, if the area of the original triangle was 40 square inches before the cut, that means area of the bigger triangle is given as 40 square meter. What is the area of the smaller triangle in square inches? Area of the smaller triangle BC1C2. Let me call it as AS. I want to find the area of the smaller triangle. Now see here. Simple. Area of bigger triangle divided by area of smaller triangle is square ratio of the square of the corresponding sides, where I am using my method 1 in this case also, right? So here it is 100 square, right? Here it is 100 square divided by, here the corresponding side is the other hypotenuse, which is 65 square. 100 by 65 whole square. This is 5 into 20 and 5 into 13. So it is 20 by 13 whole square. But it is given in the question that bigger triangle area is 40, smaller triangle area is how much? So this is 40 by AS is equal to 20 by 20 into 13 by 13, 20 into 1, 20 into 2, 2 into 1, 2 into 10. So this is nothing but AS will be equal to 13 into 13, 169 divided by 10, which is nothing but 16.9 inches square, right? 16.9 square inches. Answer for this question is option A. This is by using method 1, wherein I will write all the details of what is required. AB by AS is equal to 100 by 65, all those things, and then solve it. Sir, can I use a different method? Definitely, why not? Why not? Method 2. Method 2 says that I will make both the areas same, although in the diagram it is not true like that, but let me make it so that we will get the answer in diagram itself. The bigger triangle, let me write the diagram once again for your better understanding. Bigger triangle is triangle ABC. I will cut this triangle ABC at 2 points. Those 2 points are C1 and C2, and when I join those 2 points, it will be parallel to the line, will be parallel to the hypotenuse. That means hypotenuse of smaller triangle and hypotenuse of bigger triangle, they both will be parallel. Now question says that bigger triangle hypotenuse is 100, hypotenuse of bigger triangle is 100. The question also says that area of the bigger triangle is 40. Now the entire bigger triangle area is 40. Let me write it here, right? Area is 40. Now this is what is given, and there is a 35% reduction in the hypotenuse for the smaller triangle. That means if it is 100, this will become 65. But our basic understanding of similarity of triangle says that if two triangles has to be similar, area should be perfectly numerically same. For area to be same, I can also say that corresponding sides should be same. That means that 100 is the hypotenuse of bigger, smaller is 65. Make 100 and 65 both as same. LCM of 100 and 65, it is nothing but 1300. Sir, how did you tell so fast? Please refer to my time and work class. So 100 should become 1300. 100 should become 1300. Multiply by 13. If the side of the bigger triangle is multiplied by 13, area should be multiplied by 13 into 13, 169. Similarly, 65 should be multiplied by which number so that it becomes 1300? 65 into 20 is 1300. 65 into 20 is 1300. Can I also say that initially smaller area? Do you know the area of the smaller triangle initially? No, you don't know the area of the smaller triangle. So can I say that if the side initially it was having some area, smaller triangle was having some area, I don't know how much it is, and this area is multiplied by, if the side of that smaller triangle is multiplied by 20, then the area is multiplied by 20 square, 400. But 400 I can write it as 40 into 10. Sir, why did you write 40 into 10? Because here it is 40, here also it is 40. 169 is there. Which number when multiplied by 10 will give you 169? 16.9 only when multiplied by 10 will give you 169. That means the initial area of the smaller triangles can be so beautifully calculated as how much? 16.9. In the diagram itself, everything I found out so easily. What is the use of writing all these things in our exam? It's of no use. Sir, did I get the same answer in method 1? Definitely yes. I hope I am making very beautiful sense in teaching this concept of similarities. If two triangles have to be similar, then the corresponding angles should be equal. The ratio of their corresponding sides should be equal. That is what your textbook method, which I call it as method 1, says. But I say it in a little different way, saying that if two triangles have to be similar, then if you put one triangle on the other triangle, they should coincide so beautifully. That means the areas should be equal for the two triangles to coincide. All the corresponding sides numerically they should be same, and corresponding angles also numerically they should be same. And I called that as method 2 in so many of my questions. A difficult question which you think it as difficult in CAT 2003 can be solved within seconds in diagram itself by using method 2, which I call method 2 as ANC method. Kindly keep following methodologies of ANC. Success is definitely yours, and I am damn sure about it, sir. I hope it is very clear how to find the area of similar triangles.